to question number 5. All right, so how do you find the prime factorization of 75? So what is a factorization, first of all? So we need to talk about what factors are. So factors are basically numbers that, when multiplied together, will have a product of another number. Okay, so that was explained poorly. Okay, so a factor of a number are the numbers that, when multiplied together, will make that original number. So, for example, let me use a general example here. Let's say that we have number A. Okay, so its factors will be a pair of its factors will be C times D, which are just numbers, and we call these factors of A because when multiplied together, they produce A. Okay, so let's run through some examples. All right, so the factors of, let's say, 18, right? So obviously, one of the factors will be, let me put this in red, actually. So let's do the factors of 18. So the factors of 18, obviously, one of the pairs of factors will be 1 times 18. So anything times itself will be a pair of factors, okay? What else is a factor of 18? Factor of 18 is 3 times 6, okay? And another factor, let's say, is 2 times 9. Okay, so these are some natural number or integer number factors for 18. Okay, so what it means by prime factorization is that we want to find the prime factors of a certain number. And what it means by prime factors is that the factors consist of prime numbers. And prime numbers are another definition that we need to cover here. And prime numbers are basically numbers that cannot consist of any other multiplication other than 1 and itself. So a good example of a prime number is 2, right? So 2 has no other factors except for 1 times 2, right? Another prime number is 3. The only factors that comprise 3 is 1 times 3. Another factor is 5, right? And we can keep going. So these are called prime numbers, and there are a ton of them. A good example of a larger prime number will be 31, right? So there's no other factors that comprise 31 except for 1 and 31. So when they ask us to find the prime factorization of 75, they want us to look for the prime factors of 75. Okay? So let's think about the prime factors of 75 here, okay? And I guess another thing that I need to cover is that factorization doesn't really need to be consisted or to be excluded to pairs. They can be triplets of numbers. It can be quadruplets of numbers. And a good example here is right here with 18. With 2 and 9, we can further break this down to 2 times 3 times 3. This will still make 18, but these are a pair or a triplet of factors that comprise 18. Okay, so in the same way, we're going to try to do that with 75. Okay, so we're going to first of all think of a prime factor of 75. So we're going to do a trial test, and we're going to divide 75 by 5 because we know that 75 is divisible by 5. So that gives us 25 times 3. Okay. All right. So now we know that one of the pairs of factors is 25 and 3. Okay. Now, are these the prime factors of 75? No, because 25 is still divisible, right? It has factors of 1 and 25 and 5 and 5. So we're going to use that, right? So 25 has a prime factorization of 5 and 5. Okay? Are these prime factors? Yes, they are, because the only pairs of factors that comprise 5 is 1 and 5. So we have found our prime factors, which is 5 times 5 times 3. Okay, so this is the prime factorization of 75, which is prime factorization, okay? Right? So these are the prime factorization of 75. Okay, in the same case, in my previous example, the prime factorization of 18 can be characterized by two times 3 times 3. So that is another prime factorization. So yeah, that's how you be able to do the prime factorization of a number. Okay. So this solution is correct. Good work. Cool. All right, let's move on to the sixth question.